Whether it be learning how to ride a bike, using unfamiliar cutlery for the first time, or honing your musical talents, we all embrace the try, and try again mentality when developing essential skills. So why does education seem so incompatible with this approach? New Zealand educator Brent Mawson was interested in this very question in relation to STEM, an interdisciplinary approach that combines science, technology, engineering, and mathematics into one all-encompassing classroom. For Mawson, traditional STEM education utilized a linear design, make, praise structure that made assessment easier for teachers at the expense of student learning. With a heavy focus on final product evaluation, the linear design model problematizes failure as the ultimate sign of a bad student. The final grade is paramount and the process loses relevance. With this linear approach, students become risk-averse, are less likely to engage creatively, and lack the genuine collaboration emblematic of most STEM field professions. Moreover, students actively rebel against this rigid design structure. When faced with the requirement to follow a prescribed linear model, students tend to subvert the design process by adopting their own strategies to get the job done, but ritualistically use the teacher's approach to satisfy assessment requirements. So, if students aren't using their work to engage in problem solving, what is the point of forcing them to jump through these prescribed hoops? Mawson suggests embracing a more cyclical approach to STEM, where students engage with content and develop essential skills. A mini product development loop is established, where peer and teacher collaboration exposes design flaws that are retooled and addressed, and students are presented with options concerning how to extend their project outside the classroom. To construct this classroom, educators should set up open-ended problems with multiple entry points, provide students with time to conceptualize their problem solving, and embed reflective elements where students justify design choices to their peers, have opportunities to test concepts, and receive mini lessons to add to their developing skills. But such a cyclical design model does not have to be confined to the STEM classroom. In history, students could create timelines in groups, share these products, and rework to create a class database for future reference. In an English or language environment, students could create, rework, and present choose-your-own-adventure stories and use excerpts when discussing writing conventions. And in physical education, students could design and share an original game, facilitate feedback from peers, and retool for a subsequent trial. Mawson's alternative design model is reflective of real-world problem-solving's organic embrace of failure. Through such an approach to learning, students will be better prepared to face challenges as they transition to life beyond the classroom.
Created using Powtoon.